So, in this case, we are going to continue from where we left, this time working with typical questions where the first derivative of one function can be multiplied to the first derivative of another function, or it can be a division like this. All right. It can be greater than zero, it can be less than, it can be less than also on this condition. So these are the typical questions that we are going to look into. So as we can see this time, guys, we do not have f of x on its own. It is its derivative. Even g, it is its derivative. So what is important are the critical values. Before we look into what is happening, the critical values for the first derivative. Remember, guys, I said it is what? From the turning points or the asymptotes when we have got the x asymptote. When it is applicable, you use what? The asymptote. But the major case, check what? The turning point. So we just gonna look into that one. So as we do know that the product to give us a number that is greater than zero, it is positive. So it's either positive times positive, negative. We are going to use that condition to give this one positive over positive, negative over negative. So it can be less than. When it is less than zero, it means positive to negative or negative to what? To positive. So that is what you're going to need. And also that the denominator, when we have got a fraction, the denominator cannot be equal to what? Cannot be equal to zero. So that is when you are given the derivative of g in the denominator, if it is of f. So here we're just going to say the denominator like this cannot be equal to what? Cannot be equal to zero. So that is it. So meaning to say, guys, with this, we can answer our questions as long we've got critical values. So on this question, we're given these graphs, and the question was to determine the value or values of x for which the derivative of g to the derivative of f, all right, is what? Greater than or equal to zero. That is being what? A positive. So it's either positive, positive or negative, negative, all right? So let's consider the two graphs and see what is happening here. G is a hyperbola. So this is our G. All right. So we have got a hyperbola in that case. All right. So remember, I said for a hyperbola, you must consider what? The critical values, which is going to be asymptotes. So here we're going to consider the asymptote of x, which in our case, it was this part. This is the asymptote. All right. Which is at what? At point B. So the point B was at 1. It was the value where x is equal to 1. All right, this is our y-axis. That says 0 there. All right, so that is for G. F, its derivative, f is what? A parabola. So for a parabola, the critical values will be at the turning point. So the turning point is at B, where we also have that as our asymptote. So it is happening that the turning point, which is at B, the x value is also 1. So that one was okay. It was an advantage. All right. So that's our critical value. We're not going to have any other one. All right. So looking into our graph, we can check, is it positive or negative? We have got what? Critical values. All right. So that is it, guys. Let us consider first our g. Remember, guys, when it is a hyperbola like that, this is what we have, a decreasing function. When it is found in these regions, it is a decreasing function. So a decrease means that the derivative is what? Is less than, so it's a negative, a decrease. All right, so that's a decrease like this. The slope is going to be a decrease, so that's a negative. So in terms of the first derivative of g, here it's a negative throughout. It's what? It's a negative. All right, Here it is also a negative. Since it is what? A decrease, it's a negative. Okay? As we compare from what? The asymptote. Then for the first derivative of f, as of f, we are measuring or comparing to the turning point where x is 1. As we can see, it is going up. That's an increase to the turning point. So going up, that's a positive. So it's going to be positive. It's going up. It's what? The first derivative is what is positive. Okay? From the turning point where it is 0 there, it is now going down. That's a decrease, a negative, remember? So it's going to carry a negative. This is what is happening on our f of x. Its derivative is going to be negative. So let us now combine this and have our solution. Where is it that we have got what? Positive to a positive or negative to a negative. All right. So our critical value, remember, it is just we have got only one critical value. X is equal to what? X is equal to 1. So let's compare to that one where x is equal to 1 and see what is happening at x is equal to 1. All right. On the left side, we can see that 1 is negative. All right. Its derivative is negative and the other one is going up positive. So this region, we do not want it because we need when both are positive or negative. So the first region is out. We compare the second region from 1 going to the right side. We can see that the first derivative of f is negative and of g is negative. This is the region that we want because negative times negative is going to give us what? A positive. So you're talking about values from the turning point, which is from what? The asymptote as well, where x is 1. So x must be greater than these values. They are greater than what? They are greater than 1. X cannot be equal, even if there is an equal to there. X cannot be equal to 1 because what? 1 is an asymptote. So x cannot be equal to 1 as we have got what? An asymptote there. So x can never be equal to 1. So we cannot have equal to there. All right, so that was it. We have answered your question, guys, where the first derivative of these terms, this one is greater than 0. Just consider, is it an increase or a decrease? There we also have another condition. For which values of x will this first derivative and this be greater than 0? All right, the first derivative of g times the first derivative of what? Of h will be greater than or equal to 0. All right, let's consider g. G is what? A parabola. Remember, for a parabola, the critical values will be what? The turning point. All right, for a parabola. So it's going to be the turning point at C. And that was, the value was corresponding to 1,5. All right, so this is a parabola. We're going to consider. Let's start with this one and see. So that's our G. So the critical values, or the critical value will be actually at what? At 1,5, which is what? At the turning point at C. So that is at the what? At the turning point. So the value was 1,5, like the one that we are going to use. And at B and A, it is not important as we are to deal with the first derivative. The x-intercepts are not even important. We do not even need to know, even if, let's say, we know these values, it's not important. All right. Then for h prime, the first derivative of h represents what? A straight line. That's a linear function. So for a linear function, guys, it's already a straight line. Remember, I was saying, is it an increase or a decrease? So that one we cannot talk about critical values because it's already showing us how the graph is. Is it a decrease or an increase? All right. So we are not worried about that one. We are worried about what? We are worried about g prime x. So g, as we consider g to the turning point, it is going down. This one is a decrease. So that is negative in terms of what? The gradient. So it is negative. From the turning point going up, it is now an increase in terms of the gradient. So that's a positive from the turning point at 1,5 there. is going up. Whereas the first derivative of h representing the gradient expression for this type of a line, it is going up, guys. It's increasing, so it's always positive. So h, guys, is positive throughout. H is positive throughout. It is positive throughout. So where is it that the 2 will give us a value that is greater than 0, which is a positive? It can be positive, positive, negative, negative. All right. As we have got two regions from our critical value, we have got two regions, the first and the second. The first region, if we check what is happening in the first region, one is positive, another one is negative. We do not want that because either both. So the first region is out from 1,5 going to the left. It does not satisfy. From 1,5, if we consider this other section from 1,5 here, going this side, we are going to see that both are positive. H prime, its derivative is positive. Guys, it is increasing, positive. And also this one for what? For G, it is increasing. So both are positive from 1,5. From 1,5, both are what? Both are positive. So therefore, x is greater than what? 1,5. Can we say it is equal to 1,5? Yes, it can be equal to 1,5. 1,5 is not an asymptote. At 1,5 here, we are saying the first derivative of g is equal to 0 at the turning point. So it can be equal to 0. So also x can be equal to what? 1,5. So we are going to have equal to on our answer, greater than or equal to. All right, so that is it. The major case there, it was the turning point. That is your critical value. This is what you have. Then you just make your comparison. First derivative, guys, increase or decrease, just like that. All right, let's consider another one just for the sake of revision. We can have also a condition when it is, let's consider the same, from the same diagram, let's consider a division so that we do not waste time like having a lot of diagrams, guys. All right, let's add another question here. Let's say it was for a division. Let's say it was g prime x over what? Over h prime x, which is greater than 0, like this. All right. Let's say it was a division. A division now, you must be very careful about the denominator, that the denominator, let's say there was an equal to, you must consider that the denominator is what? To be included. H prime x cannot be equal to 0. So meaning to say, as you consider your h, you're not going to have a condition where it is equal to 0. That is, but in our case, there is greater than. So do not worry about that. Do not worry. All right. To get a positive, on this case, it is either that both are positive, positive over positive or negative over negative. So where do we have both being what? Positive. We are going to see it is the same thing, guys. Both where they are positive, the answer was going to be on that region of 1,5. We saw that is where both are what? Positive. So x will be greater than what? 1,5 for a division. If we divide positive to positive, you get what? A positive. This region is false. All right. So we are going to focus with the 1,5, this region. All right. Let's have another one. This was straightforward. This was straightforward. Let's have another one. Let's say g prime. All right. Let's say g prime x over h prime x is less than 0. So less than means we're going to have a negative. So it can be positive to negative, negative to positive. So you find out that the region that was not valid in the first answer is now valid. That is where we have got negative and what? A positive for values of x that are less than what? For values of x that are less than what? That are less than 1,5. So guys, as long you can tell the negativeness or positive of the line of the steepness of what? Of the given function, First derivative, always gradient. You measure the way that you work out your gradient to say if you were going to calculate the gradient at any point of this graph up to the turning point, you are going to get negative answers throughout. From the turning point going up here, if you're going to draw any line and calculate the gradient, you're going to get positive answers throughout. That is the idea of what the first derivative is, the gradient expression going up, positive, down, negative. So let's revise as many questions as we can. All right? Where you do not understand, let's communicate. Let's communicate.